Alright, we're going to be completing the square to solve for zeros. So, our warm-ups are first, I want you to change this into vertex form. So, of course, we do our shortcut, negative b over 2a. So, a is 1, b is negative 6, c is 11. So, negative b is negative negative 6 over 2 times a, which is 1. So, that's 6 over 2, or 3. And then we substitute that in to find out what the y value is. So 3 squared minus 6 times 3 plus 11 is 9 minus 18 plus 11. That all adds up to 2. So our h is 3. We put it in there as opposite. Our k is 2, because that's what we got. And a is 1, so we just leave the 1 how it is, and that's vertex form. Now, solving for x here. Well, if we have to get x by itself, we got to get rid of this first 2, so we divide it by 2. We get negative 48. And to get rid of squared, we take the square root. Well, when we take the square root, we can get plus or minus. And because we have x squared, we're looking for two answers, just like we were when we were factoring. We're looking for zeros. And most of the time we had 2 zeros. So plus or minus the square root of negative 48. But now that we have a negative, it's going to be an I. We've got to take out an I. Then we break down 48. 48 is 16 and 3. 16 is 4 and 4. We can break down the 4s more, but we only need pairs, and we have a pair here. So I bring out a 4. I already had an I, but 3 is stuck inside. So x is equal to plus or minus 4i root 3. So if we were to graph this, well, we have an imaginary 0, meaning it's not going to cross the x-axis. So if we look at its graph, here's its graph. Yeah, it doesn't cross the x-axis because it has imaginary roots. That's what this is. 2x squared plus 96. That's our equation. Alright, we keep going. We look at this one. So solve for x. We have to factor because that's the only other net way we know how to do that. So 3 times 6 is negative 18. Middle number is negative 17. So the two numbers that multiply to negative 18 and add up to negative 17 are negative 18 and 1. So we split up the middle term into those, negative 18x and 1x. We couldn't do the shortcut because our a was 1. And we also didn't have a GCF. Forgot to check for that first, but I really did. So now we group them. So we can take a 3x out of this. We're left with x minus 6. And we can't take anything out of here, but we can always take a 1, so we take out plus 1. And we're left with x minus 6, and these are the same, and that's what we want. So we get 3x plus 1 times x minus 6. And remember, when we're solving, we set each one of those equal to 0 and solve for x. So x minus 6 equals 0. Add 6 to both sides, x equals 6. That's 1, 0. Pretty easy. The other one, 3x minus plus 1 equals 0. Subtract 1. So we get 3x equals negative 1. Divide by 3. So x equals negative 1/3. So we should have zeros at negative 1/3 and 6 if we were to graph this. And that's what we have. I have to zoom back into what it was before, but that's negative 1/3, and that's 6, just like we thought. So it's what it should have been. So solving for zeros. I'll zoom out so we can see all of this stuff. What are other names for zeros? Roots, solutions, x-intercepts. So what are the methods to solve for zeros in ax squared plus bx plus c equals 0? Well, we have factoring. When can we do that? Whenever possible. When we can do a GCF, when we can do a diamond problem, when we can do factor by grouping, whenever possible. Square root property was like letter B. It's when we have no b term. No x term. There's an x squared and a number, but no x term. Completing the square when a equals 1. And which is what we're going to learn in a second. Quadratic formula is when a, b, and c are big numbers, or really, you can use this anytime. But we're going to be able to use all the different things. So, square root property. Missing all the b terms. There's no just x, or just n, or just x again. So here, 9x squared equals 16, divide by 9, so x squared equals 16 over 9. And to get rid of squared, I square root. So I take the square root, so I get x equals plus or minus 16 over 9. Remember, it's always plus or minus because there's two answers. And we just take the square root of each numerator and denominator by itself. Square root of 16 is 4. Square root of denominator is 9. So we get plus or minus 4 root 3. Or if you want to think about it separately, it's 4 over 3 and negative 4 over 3. So let me draw it out separately. So it's 4 over 3 or negative 4 over 3. So we have two of them. So again, if we look at our graph, well, 4 over 3 is 1.3 repeated, and we have the negative and positive form of it. So we did it right. Number 6, we had to get negative 8, or the 8 to the other side, so we subtract 8. We get 5n squared equals 75, negative 75, divided by 5, n squared equals negative 15. Now we take the square root, but we have, and again it's plus or minus because we have two answers, but we have a negative inside a square root. So with the negative inside a square root, we take it out as I. And 15, we can break down to 5 and 3, but there's no pairs, so it's just I root 15, meaning that we have imaginary solutions, imaginary zeros, so it's not going to cross the x-axis. And if we look, can we even find it? There it is. Up here doesn't cross the x-axis, and that's what we should be looking for. So that's the whole idea. Alright, now we're going to look at completing the square to solve quadratic equations. Steps are, set it equal to 0, just like everything else. Move c over to the other side, so the number by itself. Divide b by 2, then add b over 2 squared to both sides of the equation. Keep it balanced. Factor the left side, combine like terms on the right, get x by itself. It makes more sense if we actually do it. So for number 8, we want to find our zeros. So we have it in regular form. We add our c to the other side. So we add 3 to the other side. So now I have 9 or n squared plus 2n plus something equals 3 plus something. I'm going to add something in there. I'm completing the square, so I got to add something in. So I take my b term, I divide it by 2. So 2 divided by 2 is 1. I square that. So 1 squared is 1. And that's what I'm going to add in. I add in 1 here, and I add in 1 here. So on the right side, I just combine like terms. 3 plus 1 is 4. And here I'm factoring it. So there's two ways to think about it. Really, well, there's a couple different ways to think about it. If I can get a pen, I would show you. There we go. So we're doing a diamond problem where our a is 1. Oh, I already have that here. And we want two numbers that multiply to 1 and add up to 2. So it's 1 and 1. It's always going to be the same number because we're completing the square. So it's n plus 1 times n plus 1. Or it's just going to be this number that's going to be here. And we'll see that in a second. So it's n plus 1 squared equals 4. Well, how do we get rid of squared? We square root. So we take the square root of the left side, we get n plus 1. Square root of the right side, we get plus or minus 2. Because negative 2 times negative 2 is 4, and positive 2 times positive 2 is 4. So then we subtract 1 from both sides, so I have n equals negative 1 plus or minus 2. I need two answers because it's n squared. I'm going to have two zeros. So negative 1 plus 2 is 1. Negative 1 minus 2 is negative 3. So I should have zeros at 1 and negative 3. And of course, I can check this. If I zoom in a little bit, what do you know? I have a 0 at negative 3 and 1, just like it said. So another one, number 9. So we have to kick 73 to the other side, so we subtract it. And then we leave spots open here because I need to add in something. What that is negative 8 divided by 2, so negative 9. And then negative 9 squared. So we're doing with our b term. So I'm adding in 81 to both sides. I got to balance it out, so that's why I add it to both sides. Now here, I can factor this. Again, I can do a diamond problem where I want two numbers that multiply to 81 and add up to negative 18. This is negative 9 and negative 9. So it's n minus 9 and n minus 9. Or n minus 9 squared, which is how we're writing it. Or it's just this number that goes here. That's all it is. And on the right side, we just add up negative 73 plus 81 is 8. So now I have n minus n squared equals 8. So I have to get rid of the squared. I take the square root. N minus 9 equals plus or minus 8. So I have to simplify the square root of 8. So I have 3 2's. I have a pair of 2's. I bring out a 2. And I have a 2 left over. The plus or minus still stays in front of all of that, because this is equal to this. Then I add 9 to both sides, so I get 9 plus or minus 2 root 2. And I can leave it like this. Or I can write it as two separate answers, and I'm not sure why you would. So we can check that. Now, do I know what those numbers are? I have no idea what 9 plus 2 root 2 and 9 minus 2 root 2 is. So I use my calculator. It's about 11.8 and 6.17. So let's check it. Yep. I'll move over here. 11.8, 6.172. That's exactly what I expected. So I got it right. That's good. So let's do the next one. K squared minus 14k plus 109 equals 10. Well, I need my c to the other side, so I subtract 109 from both sides. Now I need to figure out what I have to add in, what I have to do to complete the square. So I divide my b. Negative 14 divided by 2 is negative 7. Negative 7 squared is 49. Add that to both sides. So on the right side I have negative 50. And here, again, I can factor it, but really it's something squared, because it's completing the square, k minus 7 squared. So to get rid of the squared, I square root it. It's plus or minus square root of negative 50. So I have to simplify the square root of negative 50. Now already, a negative inside comes out and becomes I. So it means I have imaginary answers, meaning it's not going to cross the x-axis. I break down my 50. I have 2 5's and a 2, so I can bring out a 5. So I have 5i root 2. Now I still have k minus 7 over here, so I add 7 to both sides. So I have 7 plus or minus 5i root 2. Again, it's imaginary because of the I, so it's not going to cross the x-axis. But let's double check and see what we have here. So I got to zoom out a little bit. Somewhere up, there it is. Doesn't cross the x-axis. That's exactly what I thought. So that's good. Now we have this one. Again, we need to add 88 to both sides. So we get 90. We need to leave spaces here for what we're going to add in. So it's negative 2 divided by 2, which is negative 1. Negative 1 squared is 1. Again, this is the term that's going to be here. Or I can factor it. What two numbers times themselves equal 1 and add up to negative 2? Well, negative 1 and negative 1. So negative 1 squared. 90 plus 1 is 91. So to get rid of this squared, I take the square root. I get x minus 1 equals plus or minus root 91. I got 91 is 13 and 7. I can't break it down anymore. So I add 1 to both sides. I get x equals 1 plus or minus root 91. I can leave it like that or write it as two separate answers. I would just keep it as one answer because, again, that doesn't mean much to me. So use my calculator. I should have 10.53 something and negative 8.53. So let's double check. And that's what they are. That's exactly what our zeros are. So we did this right. That's good. So we just got to go step by step through this, and we got it. Number 12. Here, I got to add 6x to this side because I want all my x's on one side, but I want the number on the other side, so I can just leave that. So I add 6x to both sides. Cancels out over here. Here, I have this. So again, I do my b divided by 2 is 3. 3 squared is 9. So I'm adding in 9 to both sides. Again, we can factor this or do whatever we need, but it's always going to be x plus this number. So x plus 3 squared equals negative 82. I take the square root, so I get x plus 3 equals plus or minus the square root of negative 82. Well, when I break down the square root of negative 82, first of all, the negative comes out to become I, and we break down 2 and 41 up. There's no pairs, so we're going to leave it as 82. I don't know why I have 52. So I can't do anything else with this, because 41 is prime. So I subtract 3 from both sides, so I get x equals negative 3 plus or minus I root 82. Again, I have I, so I have imaginary answers, meaning it's not going to cross the x-axis. So let's check it out. Oh, there it is. Doesn't even come close to the x-axis. The minimum is all the way up here at negative 382. We're not even close to the x-axis. So 2 more to go. X squared minus 5 equals negative 4x. Well, I need to add 4x to both sides to get the x's together, but I want the constant, the negative 5 over here, so I add 5. So I get x squared plus 4x plus something equals 5 plus something. Well, I got to figure out what I'm going to put in there. So it's b, 4 divided by 2 is 2. 2 squared is 4. So I'm adding in 4, but really, this is the number that's going here. So I get x plus 2 squared, or I could factor this, equals 9, because 5 plus 4. So I take the square root. So I get x plus 2 equals plus or minus 3. I actually have a whole number now. But I got plus and minus, because negative 3 times negative 3 is 9, and positive 3 times positive 3 is 9. I subtract 2 from both sides, so I get x equals negative 2 plus or minus 3. So I set it up 2 separate problems. Negative 2 minus 3 is negative 5. Negative 2 plus 3 is 1. So I have 2 zeros that are nice integers. So let's double check that that's right. Alright, looking good so far. 1 and negative 5. Alright, we look good. We're almost there. Last problem. So we're going to add 9x to both sides, and we get negative 57 on one side. So now we're going to have a fraction. We divide 9 over 2, and I'm going to leave it in 9 over 2 because I don't want a decimal, I want a fraction. 9 over 2 squared is 81 over 4, that's what I'm adding in. So here, really, I can't factor it, but it's x plus that. So x plus 9 over 2 squared equals, well, if I add those two together, using a calculator, I get negative 47 over 4, a negative number. So I have to take the square root, because I have squared here. So x plus 9 over 2 equals plus or minus square root of negative 147 over 4. Now, I can take the square root of 4. I can split this up separately. Square root of negative 147 over the square root of 4, which is, I can take out an I, and square root of 4 is 2. So that's where I get my 2, but I break down my 147 as well. It's 2 7s and a 3, so I can bring out a 7. So I have 7i root 3. That's 7i root 3 is equal to the square root of negative 147. So I have this on the right side. It's kind of ugly, but that's what happens. Now, to get x by itself, I subtract negative 9 over 2. So they have the same denominator, so I can just put it as one big thing. Negative 9 plus or minus 7i root 3 over 2. It's imaginary, so we're not going to have any real answers. But if we check it, we can see it doesn't meet the x-axis, so there are no real zeros. They're imaginary zeros. And that's what this is all about. If there's an I, you're not going to have a physical 0. If we don't, we may have square roots that are irrational, but we can still do that. And that's how you complete the square.